This week I'm doing an experiment with refurbishing a vat. And actually this vat is not in need of refurbishment. I've got a vat that has a little dot in it, but it's kind of an experiment. And the experiment in refurbishment is, can I use QSIL 216, a silicone encapsulant that is commonly used for Form 1 and B9 creator vats, and use that to kind of refurbish the vat to say, oh, my film peeled off or whatever, so can I remove the silicone, the FEP film, and put it on. I'm testing in a vat because actually all of my vats have been very good to me. I haven't messed up any of my vats, and so I'm doing this experiment without taking off the FEP film, just doing it on top of the FEP in order to leave my vats intact, hopefully. And there's reason to believe that it can be done. This is the third time I'm making an attempt. I've made a couple of failed attempts so far. Here's one of them. Here is my last try of trying to get this into this vat in particular, and you'll see that it's all bubbly, and it's all bubbly because I tried to speed up the cure using using heat and a protocol that was described on the B9 creator forums. And part of the reason why I think I need heat is our vats are a bit tricky and a bit more complicated than other vats. Our vats are not just 4 solid walls glued together with epoxy or with acrylic solvent. They're made of acrylic, like others. They're not made of glass, but we also have a whole bunch of layers of stuff and sealants, and that creates a problem because this was my first try. My first try here looks good, but you'll see that the resin, and well, you may not be able to see it depending on the angle, the resin in the edges here did not really cure well underneath just at room temperature. And I suspect that this is something that was mentioned to me in mold making class at the tech shop, that this may be a platinum catalyst silicone, which are very finicky about not curing when they're next to certain materials. They won't cure against some materials they don't like a lot. In this case, this is a used vat. You can see that there's a little spot. You may be able to see there's a little spot here, there's a little bubble on my vat. And this is the vat I was originally going to try to refurbish. I'm still in the process of seeing whether I can salvage this. What happened was basically after about 50 hours of setting, it was clear, but the corners were still liquid, they hadn't set yet. And so I put this in the oven at about 170 degrees Fahrenheit as a heat curing protocol. And that set up the resin nice, but 170 not that hot enough that it warped the vat. Our vats are probably more susceptible to warping in this dimension, right? Along the dimension that it normally bends in, because it deliberately so does not contain any solid ribs across this way that would prevent the bottom from warping, because we want the bottom to bend. And so yeah, I could, rip these off and replace them with solid strips of acrylic that I laser cut or something, but that would defeat the purpose. The bed would become, the vat would become useless, because then it wouldn't flex like the flex vat is supposed to. And so we do need some heat to promote curing, because I know that heat will cure this, but not too much, because if I put it in the oven at 170, which is the heat you need, it causes the vat to warp. And I've been trying to unbend it, and it works a little bit. This is a lot less warped than it was when it first came out of the oven, but this vat may still be toast. And that's where that the bubbly piece of silicone comes in, because in my next pour I poured the silicone into this vat here, and then I did a microwave protocol, which is basically to put it into the microwave for 5 minutes, rest for 10 minutes, and then do that 4 times. That 5-minute in the microwave, also too aggressive for these vats. After about 3.5, I noticed the vat was also trying to get warped from the heat, so I pulled it out, and I was able to flatten it out. So this vat is okay. I think I managed to save it in time. But what happened was, even that short duration of curing, what that did was set the silicone way too fast. And as a result, it set with bubbles in it. So what I'm thinking now is I'll have to leave it, put it in here. I'll pour, and I've already mixed it. It's mixed up in here. You do want to use a disposable cup. I have some of these nice paint mixing cups, but one of the problems with silicone is that it's real soft. So you can see I used a fork to get a bit of the extra out, but there's still all the silicone on the side. It's going to be pretty hard to clean up. So I would recommend for this stuff, even though I usually use nicer cups and then clean them up for polyurethane molding, or polyurethane casting rather, or for resin mixing. For silicone, because it's so soft and kind of hard to clean up, and because you need this pour to be optically pure, I can't allow any of the little flecks to get into this resin in my next, into the silicone in my next pour, because then there'll be flecks inside the plate. I don't want that. And so I would recommend you use a disposal cup, use it only once. So I'm going to do the pour, and then I'm going to leave it in a flat spot, and the only flat spot, flat relative to my printer that I have, is right on the printer. And that's part of the reason why I want to find a way to speed up this 48-hour cure process, because if I use the printer itself as the curing spot that's nice and flat to get the flat surface, then then my printer will be out of commission for 48 hours. And so what I'm going to try, the protocol I'm going to try now is to put this in here, and then I'm going to leave it for about maybe 4 or so hours. And then after 4 hours, or however long it takes for it to get clear, then I'll start putting in the microwave. I'll give it about a 2-minute zap. I'll let it sit and settle back down, and then maybe give it another 2-minute zap to encourage it to cure faster. So I've got it mixed up 10 to 1. This stuff I bought on eBay. It's not very expensive. It's about $30 for 16 ounces. I was originally using way too much. I started with 150 milliliters, which this is like 1.01 specific density. So 1.01, 1.02, they're really close to water. So that's about 150 grams total. And I've dropped that down. You don't need nearly that much. You only need about probably, I have 90 and 90, so I have 100. 90 grams of part A and 9 grams of the catalyst part B. So I'm going to now, I'm going to pour this in. And there are all these techniques for pouring that do apply, like, a thin, long stream, which reduces the bubbles. But then, of course, that might make your pour take forever. You want to kind of get it all around to make sure that it has an easier time getting out into the corners and into the centers. try to get this evenly across the surface, pouring in the thin stream to reduce the number of big bubbles. Small bubbles I can't really do anything about. We're going to have to let the curing process take care of that. And probably could use less than 90. I think I have enough in there now that this would cover the whole thing. So perhaps you could even be more saving. This is about 16 ounces, which was like what, like 400 something milliliters. So maybe I could go down to 80. Times 5 is 40, and maybe get 5 vats out of it if I was only doing 80 milliliters. And that would be pretty good. I mean, that would be only $6. Oh, whoops. Talking and pouring. I got a little on the wall. That's okay. This stuff, once it dries, it'll come off. It doesn't stick, but it has a lot of vacuum force. So it'll come off as one solid piece once you get a good grip on it. Of course, once it's mixed, I can't put it back, so I'll say, oh, I didn't need as much, but it's too late. It's all mixed up, so I might as well put it in there, which will help the side sealing, I guess. And it will cure quite, even though I've left the FEP film and all the layers on, it'll cure quite clear. And it will, of course, change the zeroing. I'll have to re-zero because now the vat floor will be higher than the stock vats. But that's not such a big deal. Whoops. All right, so now let's scrape out. Okay, so that is done. Clean up a little of this spill that I got. I always make a mess with the liquids. All right, and then let me take a look at this, and yeah, it's not bad. So I'm gonna go put it on the printer in about the position it's going to be when I'm printing, so that I'm sure that it's nice and it's flat with respect to how I normally print. And then I'll cinch it down kind of a standard way that I would if I were printing. Set this here. And then to keep dust from getting into it, cover it with this, just because I'm going to keep on checking it for a while. But it already looks like a lot of the bubbles are floating up, so with the thin stream, this might only take a couple of hours. And then the tricky part, when I get back, is going to be, if the bubbles are all cleared and gone, is how I'm going to carry this while maintaining levelness over to my microwave. Microwave isn't level, And so I don't actually want to fully heat cure it. I only want to kind of give it a little bit of a jump start, a little nudge, in order for the tough to cure surfaces by the edges, which seems to be wherever there's kind of like there's a silicone sealant already holding the walls on. Whenever there's kind of like the silicone on silicone contact, there seemed to be a bit of trouble curing. So I'll have to see what it does. This one probably won't be a success, still an experiment. And then we'll be back in, I don't know, hour or two. So I've got a bit of the vat refurbishment experiment going on here, and I'll have to fill you in that what I was doing last time, pouring QSIL on top of the FEP and everything, did not work. Got a long post in the forums about it. Basically what did work was ripping the whole bottom of the vat out, including all of the silicone. So practically speaking, what I did here is only useful if you've really reached the end of life on your stock vats. So say your life cycle with the stock vat is likely to be, first you get bubbles and stuff under your FEP, so you take the FEP off and you replace it. Eventually you might get some damage to the silicone layer below that, or you might decide that you want to actually use the silicone layer and print on the original silicone and then war the silicone layer that way. And so once you've used up the end of life of the silicone layer on the original vat, that's when you might consider refurbishing that vat into the kind of the equivalent functionality as most of the other stock vats out there. And so after ripping out the original silicone, I poured, or I cast rather, QSIL 216 underneath that, and when the vat was all real clean, I didn't have any problems with setting in there. After 24 hours it was fairly good, and I hit it with a heat gun. Now 48 hours later, it's totally fine. One warning is that my take this time has a bunch of bubbles in it, and because I hit it with the heat gun too early. I hit it with the heat gun while it was still poured, within say the first 15 minutes, and that was a bad idea, because a proper cure setup will cure pretty fast. Hitting it with the heat gun, it started to cure right away and didn't have enough time for all the bubbles to come out. So I would recommend leaving it overnight and then maybe hitting it with a heat gun to speed the cure. After that, you probably have your vats ready maybe in as little as 12 hours, definitely within 24. So the vat is in, and the QSIL 216 is very, very clear. And so you can really barely see it here. And here's my hand underneath it, right? It's quite clear. And it is a little sticky to stuff coming down on top of it. What that means is if I go down to Z home, what's going to happen is when I reach the bottom here, you'll notice that it will stick a bit before I raise it up and pour resin. So this really is the last ditch attempt. When I took the bottom out, it also damaged the silicone corners here, because these corners here, right, are put on top of the underlying silicone. And so I had to kind of fix up the corner seals. What I did was I got a bunch of these 3 milliliter oral syringes. You can get like 100 for $20 from Amazon. And 100 is a good deal because you might be able to get 10 for $10, and then for $10 extra you get 90 more. They really want you to buy 100. And these I intend to use for pigment, so that the Tap Plastics pigment, which comes in this ultra inconvenient bottle here and caused me to mess up the mix last time, I'm planning to put inside of this. But the other thing that this thing is good for is I dispensed the RTV silicone, the marine grade. Where'd it go? Here we go. Marine grade RTV silicone. And I poured this into the back, into this bit first. Hopefully that'll help me, you know, you only get one of these, so this only works once. More easily dispense this stuff. And actually it was really easy to put a controlled squeeze on these corners with this thing. So these 3 milliliter syringes, I'm going to find a lot more use for these in the future. So I've gone down to the bottom. You'll notice that when I come up, it is a little sticky because that bottom is soft, not as slick, at least to dry surfaces, than the FEP. And so the question is, what is the release going to be like when I run an actual part? So I've got to put some resin in. So again, this is the black pigmented Fun to Do resin. There should be enough, I think. Maybe not. That may not be enough. Looks like I'm going to need more. Alright. There we go. Mixed up underneath there. Alright. Actually, I was a little too miserly with that. I still want even a little bit more. What I will be printing is kind of a full plate calibration part. It's actually 6 calibration parts arrayed out across the build plate, so I can see what the forces are like. Across the alright, so we're there, we're zeroed, and then I'm gonna run. So laying down the attachment layer. This will be 35 seconds. Yeah, so I have to kill 35 seconds while we look for the attachment layer to go down. So I'm not really going to see much of a difference in whether or not this sticks more or less on the attachment layers, I think, since these layers go on real slow. I am noticing that my vat is a little warped, probably from some unfortunate encounters with the microwave. I would have to say, for if you want to do this kind of last ditch vat refurbishment, no microwave. If you need to use some heat, use a heat gun. I got one for real cheap. This thing is just perfectly adequate. This thing was like 12 bucks or something. And use that to apply heat to the surface of the silicone and warm it up. It turns out when there's nothing chemically that interferes with curing, when there's nothing chemical that interferes with curing, the heat gun is perfectly adequate for speeding up. And then you can feel the temperature of the acrylic and make sure to stop when the acrylic starts to get warm. That way there is no accidental warping. So I'm going to let it run up to the support layers, and I'll come back when we have some of the support layers going down. So I'm up here on layer 41 now, which is in the middle of the support region where the supports get thinner. You can see that the vat isn't getting pulled up that much since the supports are thinner. There's less force now. Roughly speaking, probably about the same as the behavior was when I ran this on the stock vat. And really it's going to be hard to compare until we actually get some of the part. Usually I don't print the entire calibration part. Once I get maybe 300, maybe 60 to 90 layers down above the supports, that's enough for me to measure, and so I'll stop there. And so we'll see whether at that point what the differences look like. So here we are at layer 110, and something bad has happened. It seems like I'm not lifting enough for this part to release. I would have to, if I were to continue, I would have to compensate by holding down this end a bit to make sure that it completely pulls off. Yeah, it's not releasing by the time it hits the top of the 4mm. So we went up to layer 122. And stop it now. So I'll stop it now, and then I'll switch over to another build plate and to the stock vat, and we'll compare what the differences are. Ooh, that's interesting. I lost one. You can see it floating over there. Alright, let's see if we do better with the stock vat. So I've got the original vat. This is the second of the two original vats I got with my Kickstarter. Got that back in place, and I am doing a run. Exact same thing. I just hit the run button again after re-zeroing. So same settings, same slices, same everything. This is the second attachment layer, a full 35-second exposure going down. And it's pulling up. And of course, this layer always pulls up quite a lot. So I think we're not going to see a lot of differences. So as we get through the support layers, maybe somewhere around layer 40, I'll come back just so we have a comparison of what layer 40 or so here with the original vat looks like compared to the PDMS only vat. And then we'll go all the way up to maybe layer 110 or so where we stopped last time and see what it looks like. Whoops. I missed layer 40-ish supports. So now we've entered the solid section of the calibration part. All the parts so far seem to still be attached. We're at layer 65 now. Ooh. Alright. We've got a problem here at layer 65. Oh, there we go. We dropped. Let's see. That previous layer did not drop. Very close. We're dropping just as we change direction. That's closer than I would normally like to cut it. But I might have lost a part. I think I lost a part. also starting to run out. To add some more. Dropped on its own that time. Not drop that time. Interesting. So with the stock vat, to lift more, I didn't even make it to layer 100, at layer 81. I have lost something. Interesting. So I lost 4, fell off the build plate. I have to go back to the drawing board. The first time I printed out this build plate, all 6 came out correctly on a stock vat with pretty much the same settings. So now I'm not sure why I lost 4 by layer 90. But interestingly, it would indicate that the pure PDMS vat is somewhat less sticky than the FEP surface, which does somewhat jive with what was reported by people who were making FEP only vats on buildyourownSLA.com, who'd said that their FEP vats were usable but stickier. But where we're at with the stock vat, seems to be So it's likely that at least with the V1 vats, at least until I do some more experiments, there may be a price to be paid for the toughness of FEP compared to an all PDMS vat design. We can see here some of the differences between the FEP vat came out 5 out of 6 stuck with the build plate. You can see they all have some problems, right? So we printed like this. So this one came out the best. This is kind of in the back right side of the print of the vat. This came out with the best. All 4 corners are still attached. This guy, one corner here, the supports didn't fully attach, and so it got warped. And then this guy shows that some of the pulling force as we came up pulled up the attachment plate from the vat, from the build plate rather. And in this we see a lot of times when there's a solid attachment surface. The solid attachment surface is more sensitive to the whole thing coming up due to warping compared to when there are points and the attachment surface is not solid, but rather each circle is distinct. It seems to resist that a little bit better. And these two here also show warping strangely in the opposite side. And this is something also a little bit weird, that this middle guy, if I put this back on in the same orientation as a print which is here. Oh, okay, so this guy's been warped since it came off, so it's hard to see. This middle guy is warped, pulling down on the front side, and these two way on the front, the most flexible end of the vat, are warped on the opposite side, with the warpage and the gap facing towards the back, which is a little strange that these oppose each other like this. One would imagine that whatever the directional forces are for the vat flex, they would be the same, or they would at least face the same direction, have different magnitude. But that clearly is not what happened here. In this one, interestingly enough, although we say that the separation forces are the most spread out on the flexible end, it is the fixed end. And it's only the fixed end that survived. We can see that this guy is stuck down pretty well. This is the left side, the warped one, the one where one corner came up in the first test. In this one, we can see that there is some separation here. Of the attachment layer facing the front of the vat. So that is interesting. Yeah. So that is the experiment for today. I guess it means that going with the less durable vat may still be worth some experimentation. I'll keep on trying and then post back.